Section 6.3 Sampling, Distribution and Estimator. Now, what is the sampling distribution? Now, I'll give you one example here. Section 6.3 Sampling, Distribution. Okay. Now, assume that this is the population. Okay, this is entire population of your data set. Now I need to find out some parameter. Now this parameter can be anything like mean, standard deviation, variance, etc. So I want to find some parameter of this whole population. Now, as you know, as we are studying from chapter 1, we cannot do this using the whole population. So what do? We take a sample, right? We take a sample, some size, it could be any size, and then we find out a mean or some parameter. So parameter of that sample is called as statistic. So this statistic means it could be mean, standard deviation, variance, etc. Okay, and I will use this statistic to find the parameter of the population. Okay, now likewise I will be picking up some random samples. This is sample 1, sample 2, sample 3, and so on, and I will be finding out, let's say, the mean. Okay, let us stick with this. Now if you are doing this, if you keep on doing the sample sizes and calculating the mean of the sample, finally what we do is we sum up all this mean, or we take, let's say, compute, we find out the mean of all the sample means, all the sample means. Now what is sample mean? That means this one. Okay, the mean from the sample is called as sample mean. Very easy to understand. So compute mean from all the sample means. Okay, and this mean will be equal to or close to, will be equal to the mean of population. Okay, mean of the population. Now this distribution, the picking up the samples randomly, finding out the mean, that distribution is called as sample distribution. Okay, sample distribution. Okay, so this is what the theory behind this. Okay, so I don't want to read the sentences here. You can easily understand. Now, next is biased and unbiased estimator. Now, what do we mean by estimator? What do we mean by a estimator? It is a statistic which is used to estimate the value of a population parameter. That means, for example, in the previous example, we saw that in this example, I told you that we will use a sample mean to find the parameter, right? Now, this sample mean is called as estimator. Got it? So that is the meaning of estimator. Now, in estimators, we have two types, biased and unbiased. So what is unbiased? Unbiased means if a statistic targets the value of the population. In a simple words to say, for example, if I take a mean, the sample mean, if that is equal to the mean of a population, then that estimator is called as unbiased estimator. Okay, what is biased estimator then? If it is not equal to, then it is a biased estimator. Got it? Now, some examples. These two are the examples of unbiased and biased estimator. Okay, now the median, range, standard deviation of a sample cannot be equal to and will not be equal to the median of the population. Both numbers will not be same. Okay, for example, if I say I'm just talking about the sample here. I have sample and population, sample and population. If I say here the median is 2, here the median will be different because this is entire population. Okay, for example, let me take some numbers here. Okay, now here I'm taking 1, 2, 3. Okay, so now do you agree with this that if I say 1, 2, 3 is a sample, do you agree? Yes, because I said this is a population. Now I'm taking a sample from the population. Okay, now here what is the median? 3, and here median is 2. So as you can see, both are not same, and that is why we call this parameter or estimator as biased. Okay, what about the mean? So we have an example based on that. So let's do that so you will understand. Okay. So they are saying that if two values are randomly selected, that means that is the sample size. 2 is the sample size. Okay. Now with replacement. So what do I mean by, or what do they mean by with replacement? So replacement means with replacement. For example, if I say I have 3 numbers, 1, 2, 3. Okay, and I am telling you to select at least 2 or 2 random numbers. Select 2 random numbers with replacement. Now what do I mean by that? That means assume that putting all these numbers 1, 2, 3, 1, 2, 3 in a hat. Okay, now pick up one number. It could be 1 or 2 or 3. Okay, let's assume it is 2. Now I need to pick up another number. What do I do? What do I do with the already picked number? I replace with the other number, meaning I put this number back into the hat. Okay, so and then I pick the another number. So that is called with replacement. Without replacement meaning if I take one number from a hat, I should not put that back into the hat. I should just throw it away. Okay, so that is the meaning of with replacement. Okay, coming back to the example. Now you're supposed to pick two numbers from the total population, and this is the total population. Okay, now we need to list 9 different possible samples, which means we need to build up a sample space. Okay, and then we need to calculate the population mean and the sample mean. Okay, let's do that. Now population is equal to 4, 5, 9 given in the problem. How do you compute the mean? Add and divide by the total number, right? So can you add and divide and then tell me the population? So how did we do that? 4 plus 5 plus 9 divided by the total number, which is equal to 6. Now the question is asking whether it is a biased or unbiased, meaning the sample mean should be equal to 6. Okay, so let's see whether it is possible or not. Okay, now I told you that you need to pick at least two numbers from the population. So the sample size will be 2. Okay, now find all possible combinations. In other words, they are telling us to find the sample space. Okay, sample space. It could be 4, 4, 4, 5, 4, 9. Okay, and 5, 9, 5, 5, 4, is 9, 4, 9, 9, 9, okay, so this is the total sample space. I guess these are the only ways you can arrange those numbers. Now, if you calculate this, it is equal to 9. Okay, there are 9 possible to arrange the number. Now, next is we need to find mean for each pair of the numbers. So first is 4, 4, that is one random number, one pair of random number. Now you need to calculate mean for this pair, that is 4 plus 4 divided by 2, which is equal to 4. Okay, now calculate the sample mean for all the numbers and then tell me. Let me know if it is wrong. You just have to add the number and divide by 2. Then, okay. Next is, now in this sample mean which you have calculated, I want you to pick the numbers and arrange in the another column. So you have to pick in such a way that it should not repeat. So 4, I have picked 4 here. Now 4 is not repeated. 4.5, you just have to write it once. 6.5, I have 5 here. 6.5 here, and 7, and then 9. Okay, I also have 6.5. Okay, now I want you to calculate the probability. How do you do this? How do you calculate the probability? So what is the probability formula? Outcome divided by total outcome. So what is the total outcomes? 9, right? Now this is outcome by total outcome, which is 9 divided by 9. So what goes to the numerator is the number of times the number repeated. Okay, now if you see the number 4, is it repeated again, or how many times is it repeated? 1, right? Only 1. So the outcome will be 1. What about 4.5? 2 by 9, 5. 1, 6.5, 2, 7, 9, 1. So this is how you calculate the probability. So now this is done. Okay. Next is now I will create a table here. I'll just write the same thing again. Sample mean probability and x bar. Okay. So what I want you to do is calculate the third column. Use the value which is given, which you have computed. It is 4, 5, 4.5, 5, 6.5, 7, and then 9. Okay, and the probabilities are 1 over 9, 2 over 9, 1 over 9, 2 over 9, and 1. Okay, so how do you calculate this? 4 into 1 by 9, 4.5 into 2 by 9, 5 into 1 by 9. Just multiply the x with the probability of x. Here it is 6.5 into 2 by 9. We have 7 by 9, 9 into 1 by 9. Done. Now, after you calculate each and every number, I want you to add it and then tell me the total answer. Summation of x dot p of x. It has to be equal to 6. Is this equal to 6? Yes. Now, what can you conclude? Population mean and sample mean. Are they equal? So what is the population mean we got here is 6 and sample mean which we get here is 6. So it is equal. So what can you say? Mean is the unbiased estimate. Okay. So now if we go back to the table here, examples, they told that mean is the unbiased estimator, and we saw how that could be unbiased. Okay, here if you can see, median is biased because median of the sample and median of the population will not be equal. This is one example of that. Okay, so this completes your section 6.3. Now you can do this using calculator. It's a lengthy process, but calculate. Okay, I'm just giving you some steps how to do that. So in calculator, you can click on stat, edit, then you can enter in L1, you can enter the X bar, and then in L2, you will enter the probability values, probability, and then in L3, you need to compute the product of these two. So here you will enter the formula L1 and L2. L1 multiplied with L2. Okay, so after you do this, next step is click on second, quit. Next is second, stat, and this is the left button which you have in your calculator. Okay, and then go to 3, clear. Again come back, same steps, repeat it again. Now this time you will be choosing number 5. This is number 3 and number 5. So in number 5, I guess it is sum. Okay, sum. Here if you see, it will be L3. Okay, here you will get sum. Now once you click on sum, it will ask you what to choose, whether L1, L2, L3. You can click on L3 and that gives you the final sample mean. Okay, so this L3 here will be the sample mean. If you are confused doing this, you can meet me in the office hours and I can teach you how to do this. Okay. So next is 6.4, central limit theorem. Now, what does this theorem tell us? Okay, so this theorem tells us that for any population with any kind of distribution, it could be probability distribution, uniform distribution, or skewed, the sampling distribution of the sample means x bar tend to be a normal distribution as the sample size increases. That means, let's take that sample size as n. So if the n increases, according to central limit theorem, the x bar, that is the mean, sample mean, will be a normal or will be a normally distributed variable. Okay, so they say that when n increases, the sample mean will be a normal distribution. Okay, now I told you that it has to be a sample, and for this theorem to be to hold this theorem, the sample size has to be greater than 30. Now 30 is like experiment number where they say that when the sample size is more than 30, this theorem will hold. Okay, you can use this theorem only if your sample size is greater than 30. Okay, now let us study more about this. Now the sample distribution of x bar or sample means will be normally distributed or it will approach a normal if a sample size increases. And how much should be the sample size? It has to be greater than 30. Okay, now that's one requirement. Second requirement is that the sample distribution x bar can be approximated by the population mean. That means so assume that this is the mean of a sample that will be approximately equal to the population mean according to central limit theorem. That is what we saw in the previous section. And then what about standard deviation? So about standard deviation, the standard deviation of a sample means, which means of a sample, will be equal to the standard deviation of a population divided by square root of the sample size. This is the formula for standard deviation of a sample. Okay, and this is also called as standard error of the mean. Standard error of the mean. So my question is, what if the variable is already in a normal distribution? Now, central limit theorem is only because we want the variable to be normally distributed. What if the variable is already in a normal distribution? So if it is already in a normal distribution, if the original population is normally distributed, then for any sample size, it doesn't have to be greater than 30, but for any sample size n, the sample means will be normally distributed. Okay, it will be normally distributed for any sample size. There is no rule that it has to be larger than 30, only if the population is in normal distribution already. Okay, if it is not, then this will be the sample size. Okay, now we have two formulas here. Now, how do you find the probability? How do you find the probability? Or it could be area, or say percentile, etc. So generally you find this in your calculator using this, right? Normal CDF, upper value, lower, upper, mean, and then standard deviation. Correct? That is how we find the probability, right? Now, from this we get a z-score. So we need to apply a z-score to this. Now this z-score is equal to this formula. This is what we studied in the previous chapters. Now this value, this formula is used only if your sample size is 1. This is for n equal to 1. Only for sample size 1. Then z is equal to x bar minus mu divided by sigma by square root of n. So this is for sample size greater than 1. Okay, so you have two formulas to calculate the z-score. For n equal to 1, the first formula should be used. For n greater than 1, the red color formula must be used. Okay. Let me do one example here. Okay. So they are saying that elevator has a maximum capacity of 16 passengers and the total weight of that is 2500 lb. Okay. Now they are telling us to assume that all the passengers are males and the mean of this example is 182, whereas standard deviation is 40.8 lb. Okay. Now we need to compute two things here. Find the probability that one randomly selected male has a weight greater than 156 lb. Okay, so this is about one random people or a person. So n is equal to 1, then z must be equal to x minus mu divided by sigma. Okay, now here x will be 156.25. Just concentrate on the A sub question. Okay, and mu is mean, which is given in your problem, 182.1. Standard deviation is 40.8. Calculate the C. No, that is not the Z score. That will act as the X value. You know why? Because it is a normal distribution. Okay, so if it is a normal distribution, the given value will be X. Now I am finding out z-score. That's because I need to find the probability or the area. So to do that, we have these z tables, right? So I need to find the z. So it is like converting the x value to the z-score. Okay. Okay. So this value is around minus 0.65. Now this is not what we want. We need the probability of x greater than 156.25. Now we do not have x tables or x scores to find the area, so we are converting that to z-score. Now here the z will be greater than minus 0.65. Okay, so whenever you have this greater, you need to subtract the area by 1. So 1 minus p z minus 0.65. Okay, so you have to find the area of the z less than 0.65 and then subtract that with 1. So if you go back to your z table and check the value for z equal to 0.65, see if I have the z table here. Z tables. Okay, here. So it is negative 0.65, negative 0.6. I have negative 0.6 here, and it is 5. So it is somewhere here. So it is negative 0.65, which is 0.2578. 0.2578. So when you subtract this, you will get 0.7422, or you can convert this into percentage and say 74.2%. Okay, now there is one more method using the calculator. You can just use your calculator, just one formula, that is normal CTF. You just have to figure out what to use for the lower and upper value, and then mean, standard deviation. Okay, now here you already have the x, right? So I am putting the x value here, 156.25. Upper value is not given, so I will take it as 99.99, and mean, which is 182.9, and standard deviation is 40.8. You must be getting 0.7432. You just have to know how to figure out the lower and upper value. The mean and standard deviation will already be given. Okay, so once you do this, you can easily find the answer. Okay, so this was for A, sub question A. Now for B, they are saying that okay, so for B, I can use two methods. One by using the formula. So method 1, using formula. Okay, so here n is equal to 16. So what is the z formula? X bar minus mu divided by sigma divided by square root of n. So this is the formula you have to use when your sample size is greater than 1. So here x bar is 156.25. Now you might ask me that 156.2 was the x value, not the x bar, because x bar is mean, because they say mean weight greater than 156.25. They have already specified that x bar is 156.25 and the mean is 182.9 divided by standard deviation is 40.8 square root of n 16. Tell me the answer. Answer must be minus 2.61. So find the area of z greater than 2.61. Now since it is greater, I will take it as 1 minus z of less than minus 2.61. Now go back to your tables. It is 2.61, negative 2.61. So negative 2.6 is here. 1 will be here, which is 0.0045. 0.0045. The answer is 0.9955 or convert that into percentage, which is 99.52%. So this is method 1. Okay. You can use your calculator using the formula normal CDF. X bar is 156.25. Upper value is not given, so I'll take it as 99.99. Mean is 182.9. This standard deviation will be 40.8 divided by square root of 60. Be very careful with this. You cannot use the standard deviation directly. So if okay, so whenever they say greater, so this is the minimum value. It has to be greater than 156. So 156 is the minimum. So once you know which is minimum, the leftover part will be your maximum. Okay, so if the maximum value is not given, you have to take it as 99.90. Now what if, example, it is the same question, and if you have something like this, just an example, less than 156.25, that means this will be your upper value or maximum. Okay, and your lower value will be, so you have to be very careful while choosing this. So I have made a table which is there in the notes, that is uploaded in the Blackboard. You can take a look at that. Now here, when you calculate this, your answer will be same. Okay. So you have two methods. You can use your calculator or you can use the Z tables, whichever is easy for you. Got it? Now, this is for example 1. Now I have one more example. So it is similar to the same thing which we did before. Now I'm going to give you the answer for this, but I want you to calculate. Okay, so for A, the answer is 0.47. So 466, and for B, answer will be 0. Okay, and C, A or B. You have to choose which is better, A or B. Okay. So if you complete this, your section 6.4 is done. So I'm left out with 6.5. I will record that and post it in the Blackboard by today, so that you can study for the test. Fine. And I will be solving this also maybe on Friday, just for 5 minutes. So yeah, that's it for today, and we will meet on Friday. I will be doing test 2 review, so do not miss that.